An authentic 1960s Shelby Cobra will easily cost seven figures at auction, but you can get this exact driving experience for under $35,000. There is a catch. You don't buy it off a lot. You build it yourself, relying on a massive manual to piece together hundreds of loose, raw components in exactly 400 steps. Historically, the term kit car carried a bit of a sting. Early versions were often unappealing fiberglass shells based on Volkswagen Beetle frames, with parts that rarely lined up correctly. Assembling a piece of IKEA furniture with a missing dowel results in a wobbly bookshelf, but bungling the complex assembly of a 2-ton vehicle results in the catastrophic failure of the suspension at highway speeds. To safely construct a machine that can survive those forces, a home mechanic must successfully execute the same structural principles used by professional manufacturers. A car chassis acts as a simple beam supported on wheels. It needs inherent stiffness to prevent sagging under passenger and engine weight. When hitting uneven pavement, the frame requires immense torsional stiffness to resist twisting apart. Beyond gravity and road vibration, the body must withstand extreme dynamic forces, intense braking inertia, heavy lateral cornering forces, and severe impact loads. The laws of physics do not change for a suburban garage. Whether rolling off a robotic assembly line or bolted together on jack stands, the structure must maintain total integrity to protect the occupants inside. The secret to a modern, safe kit car is 3D CAD software, the same invisible digital engineering used by major automakers. Mass production factories use computers to generate perfect geometric surfaces, feeding that data to massive industrial presses to stamp out identical sheet metal. Top-tier kit manufacturers utilize this exact same digital precision. They employ $500,000 CNC lasers to cut their steel tube frame parts with an accuracy of up to 1/100th of a millimeter. Because the pieces actually line up, the builder can focus on the foundational safety elements, establishing the bulkhead and bolting in the firewall, the heavy metal barrier dividing the engine from the passenger cabin. Since the computer handles the geometric math, the amateur builder is free to focus entirely on the physical sequence of assembly without the fear of mismatched parts. There is still plenty of heavy lifting. You're muscling heavy suspension components into place, mating an 8.8-inch solid rear end to the chassis, and paying strict attention to the manual to ensure you're using the exact right metal spacers. Automobile bodies evolved from heavy steel frames with wooden frameworks into modern, complex curves of sheet metal and reinforced fiberglass. These curved exterior panels act as a stiff skin. As shown here, they take a significant portion of the vehicle's structural load, distributing forces outward from the internal frame. At the same time, this exterior skin provides the necessary aerodynamic shapes while sealing the occupants and their luggage off from the weather. By methodically locking these subassemblies and load-bearing panels together, the builder takes hundreds of loose parts and transforms them into a single, rigid shell. The final mechanical steps deliver immediate feedback. The suspension goes on, the brakes are bled, and the whir and rattle of a pneumatic impact driver tightens the wheel lugs into place. Firing up a completed car with a 5-liter Coyote engine is visceral. It is a raw, mechanical experience, a grenade-powered skateboard that responds to every input with zero digital filtering. That unrefined driving experience exists because a home-built kit is currently exempt from the thicket of modern regulations mandating electronic stability control systems and ignition interlocks. New laws will soon allow companies to sell these cars fully assembled and ready to drive right off the truck. But skipping straight to the finished product misses the point. The real reward isn't found on a window sticker. It's the psychological payoff of having artfully orchestrated a massive amalgamation of loose parts into a functional machine, knowing exactly what's happening under the floorboards because you put it there yourself.